start recording button.
Right. I'm looking for. Okay. Now, obvious first question is, has anybody had a play with Sigma Excel?
Well, we tried to play with it.
but it
Yeah.
yeah,
Unsuccessfully.
very.
I'm
Yeah.
kind of getting better. I'm getting better at it every time we do this.
Yeah, granted.
Yeah.
Yeah, I agree with that. You get more practice.
Yeah.
Okay, so as you can see, most of your options are on separate menus, and the key areas that we use Sigma Excel tend to have their own menu. So measurement system analysis, process capability, design of experiments, control charts. You shouldn't need to look at reliability and Weibull. That's something we tend to do at much higher levels. So level 6 students will cover that, they will also cover the forecasting element of it. But one of the first bits that I usually point people to is the help section. So if you drop down the help, you will find there are a number of options in there. One of the first ones really that most of us have got a copy of is the Sigma Excel guide. So here you've got a 909 page document about Sigma Excel and how to use it. It's quite useful because you can go into it and in some ways it's aligned with the DMAIC process. So for instance, if we wanted to look at, let's pick an example, a fishbone, you can click on and it will take you to the section which covers the fishbone, and it'll tell you how to get to it as well. So that is a useful document in that it gives you all the options, although when people say it being 909 pages in length, first thing they go is too big. But if you're going to be using Six Sigma and quality practitioners use Sigma Excel, then you need to know where to go. And when you haven't got the likes of myself or Beth around, this is the next best thing. So I would recommend that you download a copy of that at some point. The other one that tends to be useful, if I can remember which one it is,
Morning.
Morning, sorry about that.
That's all right. No worries. You're in.
there is another one on here, which I can't actually see at the moment. Not under guide. I have a version of it somewhere, so I'll show you what else you can actually get. There is this one. So this is a summary sheet, and it's just basically on 2 pages of where the tool can be found within Sigma Excel. So for instance, if you're looking at a Pareto chart, what is it? What type of data does it handle? When to use it? And how to actually find it within Sigma Excel. So this is another useful document in the fact that the majority of the common tools are just on 2 pages. Now that should be somewhere within the help as well. But as always, I can't remember which part it's in. However, I can send Beth a copy of that summary sheet, and then she could forward it on to you anyway.
I definitely can.
So there's 2 documents which will help you in finding your way around Sigma Excel when you need to do things. The other one, that if you want to have a play, there is sample data. And basically what happens is when you get Sigma Excel loaded onto your machine, it will set up on the C drive a folder which contains all the sample data that's listed. So if you go into it, under Sigma Excel, you'll find that there's a folder sample data, and this is all data which relates to the 909 page document. So if you're looking at examples that they've used in that document to show you how the tool or the technique works, all the data sets for running it are under sample data. So you can follow it through in the document, and you can actually run it yourself by using the same data that they use. So there is help for you, but the easiest way to look at it is 2 common options are going to be graphical tools and statistical tools. Unless you're actually doing something specialized, such as a measurement system analysis or looking at process capability, then a lot of what you may be looking for are listed under these 2 menus. So those are usually the first place to go to. There is also an element of templates and calculators. So if you take the first option, so to make or design for Six Sigma templates, there are some of the standard templates that you would normally use in carrying out what you're doing. There is a SIPOC diagram, data measurement plan, fishbone as we've seen, FMEA, house of quality, control plan. So there are already templates built into the system, and all you would do is just click on it and it would take you straight into the template. So a lot of the way that Sigma Excel works is based around 2 things. There is the analysis of data, and for a number of different tools, there are templates available. And we've got an example here of the SIPOC. So rather than creating your own template, you can go in and use that. Likewise, if you were looking at even a value stream map, gives you all the symbols for a value stream. So there's a lot of useful information built into it that you don't have to recreate, it's already there for you. Let's get rid of those. And there are more in there. You can do a Pareto chart. Wouldn't worry about those too much, because these are all lined with hypothesis testing, and it's probably one of the things you won't cover Measurement system analysis is just a replication of what's under there, same as this one. And same with control charts as well. That to me is the only confusing thing about Sigma Excel, is the fact that the same option appears in multiple places. And because of that option of trying to do things, so here we've got a number of options related to control charts. Well, if I go into control charts, I can find them there as well. And because they're available in different places, it gets a little bit confusing, because then you start to think, well, where did I see it? So my recommendation is, if you come across something like this, and for instance, if you wanted to carry out a basic control chart, stay to the same place in the menu. Even if you come across it elsewhere, because it's there as well, stay to one place. Don't think, oh, it's in a couple of places. Always go back to the same place. And therefore you'll get used to where a lot of the information is. Okay, anybody got any questions so far? Fairly straightforward. Right. So we'll have a play with some of the simple data. Now, data manipulation is exactly what it is. If you're familiar with Excel, and if you've used any other statistical software such as Minitab, then they've all got this function to play around with the data and do it for you. So as you can see, we can transpose data, we can stack columns, we can unstack columns. We can manipulate the data to get it in a format that we can use in Sigma Excel. If you're familiar with the types of data, so generally we look at 4 types of data. We have what is known as continuous data. So this is data that can be broken down into smaller units. So length, time. Length is a good example because we can measure in kilometers, we can convert that into meters, we can convert it into centimeters, we can convert it into millimeters. And if we wanted to, we can have a decimal point. So continuous data is always something that we can break down into smaller units and likely to go down into decimal points. We have discrete data, which is where we count. So in this case, it's going to be whole numbers. I've got 10 defects on this particular widget. Or I've got 50 defective units. It's always a whole number. So discrete data is always a whole number. Attribute data is where we actually allocate an attribute to it. And the easiest one to understand is binomial data, whereas we only have one of 2 options. So the answer is either going to be yes, no, good, bad, pass, fail. And then the final version is when we've got what we call non-normal data. The assumption is that continuous data always follows a normal distribution. Non-normal data is data that doesn't, and I'll show you the difference between them if you're not familiar. Is anybody familiar with what we term normal and non-normal data? Okay. So what I'm going to do is, and you can do this yourself, if you don't want to use the sample data, then you can actually create some data yourself. So under data manipulation, random data, I can get it to give me some random data which is normally distributed. So starting from there, I'm going to have one column which has got 100 data points in it. I can tell it what the mean is, and I can also set my standard deviation for it. So standard deviation is not another way of saying variation in there. How much variation do I want? Well, I'm going to drop it less varied. And now I've got a list of 100 data points, which should be normally distributed. I can also do the same for what we term as non-normal data. So this time I'm going to create data which doesn't follow a normal distribution. And it's going to be exactly the same, 100 data points. And there's my 100 data points. So one set of data is what we call a normal distribution. One set of data is not. And keep that one. No. They're good because I can show you some of the quirks of using Sigma Excel. So we'll start with the normally distributed data. When you want to analyze it, you've got to be able to load that data into the system. Now, if you think about it, all we're using is an extended version of Microsoft Excel, because the Sigma Excel bit is just based around coded add-ins plus the use of macros. So it's a bolt-on to Excel normally. A lot of the way it still uses the traditional Excel tools anyway, but it's just got a little bit more coding in the way that it uses them. So a lot of it is completely transparent to you. The one thing I always recommend to people when we start using Sigma Excel is, if, for instance, I've got data, and we're just going to look at one column of data this time, always put the cursor at the top of the data column. Now, you can look at data which has got a label in this case, or you can look at data without a label, and you can tell Sigma Excel which it is. But if you want it to look at the right data, then go to the top of the column, and I'll show you why. So the first thing I'm going to do is I want to check whether the data is normally distributed or not normally distributed. So under graphical tools, I can do a basic histogram. Very simple way of looking at it. And with a lot of the tools and the techniques, you will get that window. And this is the window that selects your data. Hence, as you can see at the moment, it tells me that the only data I've selected is from cell A1, which ties in with where I placed and highlighted the cell to start with. We confirmed that we've got a data label. So what it's going to do is ignore that first cell. But we want to be able to use all the data. So as immediate effect, you can see now it's added the whole range of data. And if I go next, which takes me into the window to do the histogram, you'll see that whole column will highlight. So it confirms that I've selected all the data. And for most of the tools and the techniques that you use, that data collection window will appear. So for me, that always works. And then having gone into it, all I'm going to do is say, I want to look at the histogram for that data, select it, and that's what I get. Basic histogram. And the reason we say it's normally distributed is this black bell-shaped curve that's on there is a normal distribution. This is how we expect the data to be arranged, that theoretically it is symmetrical around the mean, median, and the mode. So that's what we mean by a normal distribution for data. Now, for statistical analysis, the one thing we're trying to do is ensure that the data is normally distributed because we can work better with it. If I do the same thing with the second set of data, which I know shouldn't be normally distributed, then I can still do a histogram with it in exactly the same way. And now you can see that it's not symmetrical. It doesn't follow the bell-shaped curve that the previous one did. All the data is skewed to one side. So immediately we would say we have a non-normally distributed data set, and therefore we have to do something with it, which is probably the next step. But for you, it's probably a step that you won't cover. So when you're looking at data, first thing to do is try and plot it as a histogram, just to find out what the shape of the data is. And hopefully you will have something that is normally distributed. And if you look at the options, then actually we can do 3 different versions of a histogram. So all I've done so far is just a basic histogram plot. And the histogram, if you're not familiar with it, it takes the data and separates the data into a number of ranges. And then it counts the frequency of data that actually sits in that range. So this is why we get the shape for normal distribution, because generally in the middle of the data we expect to see the largest frequency. If you want to look in a little bit more in depth, then you can do histogram, what we call descriptive statistics. If you're only interested in the descriptive statistics, then under statistical tools, you'll see that there is an option just to pull up the descriptive statistics. So you can just get the numbers off, and it may be that you're interested in just a little bit more information about the data that you've collected. So again, if I pick the same data and I'll just pull up the descriptive statistics, again, you've got the same data collection window. Use the entire data. What am I looking for? Well, I just want to look at the descriptive statistics for that data. So I'm interested in the mean, I'm interested in the standard deviation, and I may be interested in other things. So I let it go, and I get bits more information about the data I've collected. So it tells me my count is 100 data points. The mean, which I originally set up to be 0, so it's just slightly under. I've got a standard deviation of 0.57. Well, I set the standard deviation at 0.5, so close enough. Tells me the spread of data. So the range is the information from the lowest number to the highest number. And then just to confirm it, there's my lowest number, there's my highest number. So the difference between those two should give me the range. And initially, if you're not familiar with a lot of this, then probably these bits of data are the only things you really need. So we're always interested in the mean of the data. And if somebody comes along and says, I've got data, it's got a mean of this, the first thing I always go back with is, well, what's the standard deviation? I want to know how much variation there is in the data, because the bigger the standard deviation, the more variation there is in that data. So mean on its own is not good enough. It needs the standard deviation to give you the variation. So you can collect descriptive stats. They're always useful. You can do it with the histogram if you wish. If you wanted to look at the data, then depending on how the data is set up, there are two options. So again, within graphical tools, if you've got X and Y data, so if you've got two lots of data where you can plot one against the other, you would use a scatter plot. However, if you just want to take data in order and plot it in order, then you'd use a run chart. So again, using our data, I've still got the same data collection window. And now I get the option on what I'm going to do in terms of plotting my run chart. And run is the easiest way to remember it because it tells you and plots the data in the order it runs. So you're always going to go in the sequence that you've collected it. I've got no x-axis. I'm going to show the mean. I won't have that on. And that's what my data looks like. So now I can have a look at where my mean is. And if you go back to the descriptive statistics, minus 0.26, minus 0.3. So there's the mean going through the data. Here's my minimum value. There's my maximum value. So that gives me the range of data. And then my standard deviation is how much variation I've got across this. So I can look at it and get a visual on the data itself. Okay, everybody happy so far? Anybody got any questions? So I keep going on about getting into this routine of doing certain things in a certain way. If, for instance, I was in that cell and I decided, yeah, I'm going to do a basic histogram, I still get the same window, but it now tells me I'm in a different place. Use the entire data. The software is clever enough to say, actually, the range you've selected has no data in it. So it will tell you if you're in the wrong place and whether you've got the right data. So that's why I always go back to the top of the data I want to use. Therefore, I know when I select it, I'm going to get the same data. You can also have it in the fact that if you're on the wrong screen and I decide I want to do it, it will look at that spreadsheet and say, actually, there's no data on it. Go and find your data. So there are traps built into it that prevent you from doing things and wasting your time looking at things when there isn't anything to look at. So initially, first steps, I always did, and it almost becomes second nature to me, is let's have a look at the data. I'm not interested in analysing it. Basic histogram and a run chart is sufficient to tell me what the data is doing. If you want the data, then as we've said, you can use what is known as descriptive statistics. This will now give you a lot more information. Okay, everybody quite comfortable with that so far?
Yeah.
Now, there are other areas we can start to look at. For instance, see if I've got some sample data. I think. Just want to look for a specific set of data, so just bear with me a moment. Go for that one. Maybe a box plot. Another way of looking at data is what we call a box plot. And a box plot allows you to compare data across a number of different samples. So what I'm going to do with this data is I'm going to assume that we collected data on different days. So we got 4 samples on day 1. We've got 4 samples on day 2, and so on. Day 3, I'll just go down the rest. How many I've got? Oops. So I've got 10 days worth of samples. I can look at them in a way that allows me to compare them, because that's what I want to do. I want to see if there's a different day by day. And I can actually plot that data using this particular method. It's a control chart. The X bar indicates, well, it's another way of saying the mean of something. So, for instance, I can look at this data on a control chart as individual. So this is going to give me another the same version of a run chart that we did for that other data. I'm only interested in individual items, and I'm going to plot it. So there's my run chart of that data. And it shows me what all the individual points are doing. So as you can see, we've got 40 data points. However, we have collected the data on different days. So I'm also interested to know what happens, whether there's variation across the different days. So I can now take the same data, but rather than look at the individual points, I can look at the mean of each day. So if you take day 1, then down here it says the mean is 6.37 for day 1. If I now select my data, I can actually get it to plot the mean of each day in exactly the same way as we had before. Everything is in subgroups of 4. So now, instead of having 40 points, I've only got 10 points. And the reason being, this is 10 days worth of data. And if you remember, I showed you what the mean was for day 1. Well, there's the mean, 6.37. So instead of plotting individual points, I can actually plot the subgroups. I can plot the mean of each day to see how much variation there is day to day. So don't be afraid, if you want, when you're collecting data, to be able to break it down into smaller groups. You don't have to treat it always as one big group of data. And in this case, I've got 10 samples of 4. And across that, I can see that on day 4 and day 5, we got a variation. So what did we do different on those days? So within Sigma Excel, I can look at the data as one big item, or I can look at it in smaller groups, in subgroups. And this is one way I can do that. The other way you can look at data if you've got subgroups is with what we call a box plot. So in graphical tools, I'm going to pick multiple X box plots. I want to use the entire data as we normally do. I'm telling it where the numerical data is. I'm also going to tell it where the subgroups are. So this is another way I can look at the data separately and say, this is what we did on day 1, this is what we did on day 2. If I let that go and crunch numbers, I get something like that. Day 1's data, day 2, day 3, and so on. But this is a much more visual representation of the data because it shows me how much variation there is in the data that was collected that day. So as you can see, the bigger the box, the more variation there is in the data. The black line is the median. So the median is the middle point of the data. The dotted line is the mean of the data. So I've got 2 more bits of information about the data. And where I've got instances of this one, where the median, the middle of the data is right at the top, it tells me that the data is skewed and it's all on one side. So this is another way you can look at data in different ways and get information about it. So when you're setting up a data collection plan, don't always think you've got to collect individual data points. If you want to set up subgroups and collect data over a number of days, there are different ways you can analyze it. And you can actually start to look and see what's happening each day, whether you've got good days and bad days. It also works if you say looking at data collection across shifts, because if you get different shifts to collect data, you might see that there's a difference in the shift patterns that appear on your data collection. So why is one shift different from the others? Okay. Are you all comfortable with that so far? Right, go back to my original. So this is our non-normal data, this particular thing, or this particular set of data. When we actually look across here, there are a number of things down here we can do which allow us to look at it in the way that we want. And for instance, if we go into process capability, it tells us there is an option there for non-normal data. So we can deal with non-normal data directly. But normally what we would do is we would actually go through what we call a transformation. Now, this again is probably a level above where you need to be. But all this is saying is we have the ability to take this non-normal data and make it fit a normal distribution by doing something to it. So we might apply a mathematical formula to the data. And instead of being not normally distributed, it will become normally distributed, and therefore we can treat it as such. Majority of the occasions you will come across data that is purely normally distributed, and therefore you can work with it. So within statistical tools, we've got a lot of things here which are all related to hypothesis testing. So unless you get involved with hypothesis testing, there's probably not a lot in there for you to have a go at the moment, apart from descriptive statistics. Most of the initial step into what you're doing will be using the graphical tools or potentially using the templates. I would certainly recommend starting with those two first. And there's lots of different options. We've seen the basic histogram. You can do it with descriptive stats, or you can do it with what is known as process capability. So what I'm going to do now is just take you into process capability, because if you are looking at data from a process and you want to find out whether that data is stable and whether the process is capable, then this option is one of the ones that you can use for it. You'll see that you get the same option again. So you can do histogram with process capability. However, to do that, you need a set of spec limits. So with capability, you need at least one limit. Hence, if you're in a manufacturing environment and you're producing widgets which have got a tolerance on them, then the tolerance becomes your upper and lower control limits. But in order to do capability, you do need control limits of some sort, or spec limits or tolerance limits. So in this case, I'm going to say my upper control limit is 0.25 and my lower control limit is minus 0.25. So if I'm producing widgets, I would expect them to be inside those spec limits. Now, when I go into process capability, I'm going to use this option. It's known as the capability combination report, and you'll see why in a minute. It'll give me information that is already here anyway. So it's going to tell me and show me a histogram. It's also going to give me information about the data and whether the process is capable. Standard window again. So I've now got my data window for producing capability. I haven't got x-axis, so I'm only looking at data. So that's going to be the y-axis. However, spec limits for capability. So I've set these at 0.25 and minus 0.25. So now what happens is the software can go and have a look and see how capable the process is in terms of meeting those spec limits. There we are. So I get the same histogram that I had earlier. It's exactly the same one. However, it's now applied the spec limits that I've told it. Anything that's outside of spec clearly are things that we're producing that are defects because they're not meeting specification. I get a little bit of information about the data that I've put in. So again, count, mean, and I have two sets of standard deviation. So where you see this, it talks about the long term and the short term. So the short term is what we've done today. The long term is what's going to happen in the future. So as we can see, our variation over the short term, over the today or tomorrow or yesterday, is bigger than over the long term, which says that the process is getting better because the variation comes down over the long term. And we have information about the performance of the process. So at the moment, it's telling us that the potential performance is that we're likely to produce 662,000 defects per million, or 66% of everything we produce will be defective. And this is another way of looking at the data in terms of how good are we in doing what we need to do, or how bad are we and where do we need to go to focus. And if you look at that with the spec limits on it, it becomes very obvious how much data we have outside of specification. So that is a fairly straightforward way of being able to compare your data to a set of tolerances that you may have. And it will also work with things like finance. So you can use discrete data in finance to say, how many errors do we have on invoices that we send to the customer? What is the maximum number of invoices that we're allowing with errors or errors on invoices? So we can set an upper spec limit, see how many invoices go outside the upper limit. We can do it with HR, and looking at recruitment processes is a good one for that. We can do it with call centers by looking at a process of answering calls from customers by saying, we don't expect calls to go over 6 minutes. So we can set an upper spec limit of 6 minutes. However, if calls are less than 3 minutes, we may have too many people. So we can set an upper and lower spec limit for that. So the process capability becomes very good at looking at data against spec limits.
Can I ask
Okay.
a question on that, please?
Yeah, sure. Go on.
If some data I collect, I only have the lower spec limit, not the
Yeah.
upper, would that still work okay for that?
What you'll do is you'll find you'll lose some of this data down here.
Yeah, I can get the PP and the PPK, but I can't get the CP and the CPK, can I?
You probably won't get CPK because it needs to compare against upper and lower limits.
Yeah,
So it's only one sided.
Seems to want me to set a target as well, whereas I'm not interested in a target. I'm just interested in it being over the lower spec limit.
Yeah. Well, if I go in and let's do the same again, but this time we'll take it out. Yeah, okay. Go back that way. So I'll just take out the upper one. Doesn't like it.
No.
So you can't do the capability because it can't look both upside and downside. There are different ways of doing it.
If I was to look at my data and also because the lower spec is the only one I'm looking at, I could see what if as long as I set a higher spec than any I've got, it will put everything within that, won't it?
Yeah.
That's probably the better way of doing it, I would imagine, is it?
Yeah, well, I'm just going to try it because I think it may do it this way. So there we are. If you go into histogram and process capability,
it'll let me do it there.
It'll let you just put the one limit in.
Brilliant.
But you won't get all the data, as I say. So you've got PPK, which is just telling you where the mean sits relative to that lower limit.
Yes.
Okay.
Brilliant. Thank you.
Okay, no problem. Anybody else got any questions? Anything wild? Anybody drowning in numbers at the moment?
Always.
Yeah, I know. I wasn't. You're an
I
exception.
know you weren't talking to me, but I thought I'd answer anyway.
Yeah, you're an exception,
I am.
which is one way of putting it.
Cheeky.
So process capability is always useful, but as we've seen, if we've only got the one spec limit, histograms and process capability, or if we've got two, then we can go through the capability combination report. And it allows us to map our data against how well we're performing at tolerance or spec level. So we have that. Control charts is all about when we get to want to monitor performance, what we can do is raise a control chart. And a control chart is there to allow us to track things as they happen. So if we're producing widgets to a spec, they go through inspection, we measure them, we can put a dot on the control chart with that measurement and be able to see whether or not we've got the process in control. They also work for finance again. So back to my example of an invoice. Every time we send an invoice out, we check it for mistakes. And once we've measured the mistakes, we can plot them onto a control chart. And the control chart is exactly what it says it is. It's a way of making sure that the process is in control. And one of the beauties of the control chart option is the second one down, which is the control chart selection tool. It, in a way, does it all for you because it asks you questions about data and what you actually want to do. So if I go back to my original data set, and these are all individual points, but I want to see what the control chart looks like, then I can use the selection tool, and it now asks me to make a selection. So what type of data have I got? Well, because this is broken down into smaller bits, it has to be continuous or variable data. Have I got subgroups? Well, no, I've got no subgroups, so it's all individuals. Therefore, I've only got one or two options, individuals or individuals and moving range. What I always say to people, if they're going to do a control chart, you always do the individual and the moving range. I've told it now what I actually want to do. So I'm back to my data screen. And all I'm going to do is just going to switch that one on for now. Just plot my data as individual points. So it'll work out the mean for me and it'll plot it either side. And there's again what my data looks like. Now, the big difference with this is these aren't your spec limits. These are statistical control limits. The lines that I've added are lines for different levels of standard deviation. So these two lines here represent plus or minus 1 standard deviation. These two plus or minus 2 standard deviation, they represent plus or minus 3 standard deviation. And with control charts, the limits are always plus or minus 3 standard deviations. Now, what you need with the control chart is that these statistical control limits are inside your spec limits. Because as you put this up and start plotting more data on it, what you want really is to hit one of these two limits before you go outside of spec. Because if you hit your statistical limits first, it gives you the opportunity to fix the process before you go outside of spec and start delivering defects. And that's how we use the control chart. We use the control chart as an early warning to say, is the trend of the data changing? Are we getting close to statistical control limits? Therefore, we fix it before we start delivering defects by going outside of spec. Okay, that makes sense. And you can do the same if we've got, see if I can actually go back here, see if I can create some discrete data. So I've now created some discrete data. We may be counting defects. We may be counting defective parts. Doesn't matter. But discrete data is based around whole numbers. And if I go into my control charts, I'm going to use the selection tool because it makes life easier for me. But this time I know I've got discrete data because it's whole numbers, not that. I can go either way. Have I got defective units? So it doesn't matter how many defects there are. If there's 1 to 10 or 1 to 100, that part is defective. So that's one defective part, or I can actually count the number of defects on a part. If the subgroup or the sample size is constant, which this one is because they're all individuals, I can select that and it will tell me which of the discrete control charts I can actually plot. So in this time, I'm just going to go with, well, I'll go with an NP, which is number of defective. So I can go this way if I wish. I'm going to tell it there's 2. Not going to bother with those. Or no, need those. All right, you're going to be awkward. Subgroup size must be greater than or equal to the maximum count of 10. There we are. So now I can actually plot whole numbers and still get the same thing. But what it tells me is because these are open circles, it now tells me that these have gone outside of statistical limits. If my spec limit is greater than that, I need to be wary that this process is producing too much variation, and therefore I need to get it under control. So there are different ways of looking at the different types of data, but getting similar information out to enable the business to operate and remain in control. Okay, that makes sense. Okay, so I don't really want to go into too much. Beth, anything else you feel I need to cover? I'll bow to your expertise.
No, I think you've probably completely blown their minds at this point of the day. Guys, is there anything else that you particularly wanted Andy to go? Or was that a good kind of orientation to the system?
No, it's covered everything that you know that works for me.
I think the only thing, Andy, might be is where can they go if they're trying to do something to get some support if they can't remember what you told them in this call?
To me, as I say, download that Sigma Excel guide. That is by far the, I know it's a big document, but it does help. So for instance, let's pick an example of what I've been looking at. Control plan. So if I was interested in continuous data and an individual control plan, there is an option there, and it'll take me into one of the options to do it. So I've got the information of where I can go in this particular case and what the result should look like. So it is very much an interactive guide. Therefore, use it that way. Don't think, okay, it's a lot of pages to go through. If you go through the menu options and find what you're looking for, just click on the menu options and it'll take you straight to that particular section in the document. And as I say, I'll send you the summary sheet as well, because it was on here somewhere, but not sure where it is now. No, I'll send that to Beth and then Beth can forward that on to you.
Of course, no problemo.
So basically, it's getting used to following the same thing. So just very quickly to recap, once you have your data, to me, go into that first cell. And then whatever you want to do with the data afterwards, you should see that window. You can then check to make sure that you're at the top of your data. If you've got a label, yes. If you haven't got the label, just deselect it. However, instead of going chasing all the data, because sometimes, you know, I've had it where I've had thousands of bits of data, being able to take this option and just go, all right, select it all for me, means I get all the data just to push a button. And then no matter what you do after that, you've got your data selected. You're just going to go into the window which actually produces the information that you're looking for. Okay.
Yeah.
Anybody got any questions? Anything they want to look at?
If you want just specific data, you can select the specific data.
Yeah. So if I only wanted to look at a little bit of that, let's say, and I'll just do a basic histogram for it. It's told me what data I've selected. I just don't tick that box.
Yeah.
And then I can go in and I can get just that range of data.
Yeah.
Okay. And it may be useful if, as an example, so if I was to say, I'm going to call this column timing. Need to put one just to separate that. So this data I collected before I made a change, let's say. But this data I collected after I made a change. So I've now got two distinct sets of data. And to pick up on your point, Andrea, I can still select that, but what I may decide to do is say I only want to look at the before data. So I go away and look at that as what it did. I can then pick that separately, but this time, if I'm going to do a histogram of that, I need to remember that I don't have a label. And if I just select that, there's the data of the after. So I can go in and separate the data. One of the things I can do very quickly. Yeah. So I'll go back to my original data. Yeah, okay. So now I've got before and after. I'm still going to start at the top, going into my control chart and plot the individual, but I want to use the entire data. So now, as you can see, it's selected both columns. I'm going to pick my data, but I know I've got two sets of data. And one of the things is if I go into advanced options down at the bottom, I can tell it the groupings. So if I select timing, it'll automatically now see it as two sets of data. And when I actually plot this control chart, I get the two sets of data side by side. So if I've made an improvement, this is my before, this is my after. I can compare the two and see whether or not any improvement work that I've done has made a difference. Okay, that makes sense to everybody. Andrew, you're looking a bit puzzled.
No, it's not you. I'm trying to listen to two conversations. Apologies.
That's all right. No problem at all.
I'm proving the fact that men can't multitask.
Well, I always say women only multitask, so it gives them an excuse not to finish anything.
Very brave.
Oh, it is. I'm only saying that.
Oi, cheeky.
I'm only saying that because the wife's not here. So, yeah, anybody got any questions? Okay.
No.
Anything else from you, Beth?
No, I'm all good. Thank you very much for your time today. Much appreciated.
Yeah, that's no problem.
I will put the recording of the session on our resource channel so you can find it.
Yeah.
Yeah.
Yep.
Okay. And As I say, most of it follows the same format, so just have a play with it, and if you want, and if you do go into the guide, it also, as I mentioned earlier, tells you which sample data you can use to replicate what's in the guide anyway. Okay.
Yeah.
Well, thank you very much for your time, everybody.
Thank you.
Thank you very much.
Thank you, Andy.
Cool. Thanks, Andy.
you.
Thank you.
Cheers then.
You're a star.
Thank
See you in a bit.
Thanks. Bye.
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 Bye.